So we are, Eric, starting undoing derivatives. That is called integration. Yay!
Integrating. Wait,
So-
integrating is a word. Shouldn't there be a
Antiderivatives are integration, and antiderivative is a word. Okay, so calculus started because they wanted to know the instant rate of change. That thing was the slope, and we did that by painfully, Ryan, doing that limit definition of derivative, and then we're like, you know what? There's some shortcut rules that would make this a whole lot easier. And that was why we did the review of stuff yesterday. Well, I gave you guys a whole bunch of derivative problems to do, and how did they go? Did you do them?
Honestly, no, I didn't. Not my favorite.
I did them.
They were all kind of
okay.
Some of them were like not that bad, and then some of them were not that
You
good.
know I got it or I didn't?
Yeah.
Oh, wait. I still don't know.
Felt like I was going wrong on every
Although there was like, I would say there was like definitely 10 where I was like very confident on what I was doing. Which like, I think that is success.
Did you do it?
I don't know.
Did anyone get number one for like the second half?
I was thinking of a change. I thought that was
No, like
like
two, find your two to the next one. I didn't know it was funny.
That's really not. Yeah, that's what I'm
Okay,
saying.
I did post the answers, and 14 and 15, I believe, of the second column are what I call challenge questions.
I feel like you throw those on the test a little bit.
So Bill,
All right, guys, really, shush. So these all reasonable. You need to be able to deal with powers of all different sorts. If they're negative exponents, fractional exponents, or just positives, you need to be able to deal with them. Power rule should be easy. This one, you should be able to do the derivative of basic trig functions and know to do chain rule. Chain rule, this one is a -5. Okay? Yes, you need to be able to do secant as well. This, you need to be able to do quotient rule. Solid. You need that. This one, divide and conquer. Reduce the things first, and then it's easy. This one, multiply by the power, lower the power, and then chain rule. This is not a product or a quotient rule inside. That 1/5 is a coefficient. Just pull it out and then do the derivative of the thing inside. All right, tangent to a power. Big time chain rule, there's 3 steps. This one was a trig identity, made it easier, kind of a pain. Fractional exponent chain rule. This used the trig identity of cosine squared plus sine squared is 1, and then it's the square or the derivative of a constant, which I don't care what the constant is anymore. It's a constant. The derivative of that flat horizontal line is 0. This guy, do the double derivative. That one sucked.
Yeah.
And this is an AP class. If it's not good for you, there's the door. Counseling's upstairs on the right.
It's either that or Miss Krieger. So.
No, it wasn't that bad though.
All right.
Would
The
you
ones-
care to go over
Okay,
class?
hold on. I don't believe that I did these. These patterns, you're not going to see them. I don't care. So I can show you how to do them. You're not going to see them. These guys, this 15, there's a step to it first that I multiplied by e to the t on the top and the bottom, and then it became easy. 14, I showed and test BC Calc on that. It is never on the exam that I have seen. It is supposedly in the curriculum. Never seen it. AB Calc, I don't know that it's in the curriculum or not, but if it's not in, if I've never seen it in BC, I'm thinking y'all are good not doing that. So we're just going to let that one slide. Okay? What about? So the,
No. You know what?
hypothetically speaking, check the answer key that's posted. Yeah.
Somebody didn't do the homework.
E to the what for 9? I couldn't tell what that was.
Number 9.
Yeah.
E to the k times x.
Okay.
But this one, hey, what's up?
Hi, Charlie. Where have you been? You haven't come to my chem class.
Children, let him go. Bye.
It's already sensing.
Okay. I need you guys to recognize when a problem is easy. This one is easy. There is some basic pre-calc prerequisite thing to do first. A times x. A is some constant. What is e to the ln of who cares? It's who cares. E and ln undo each other. So this is just them being mean and saying, oh, it's just a times x. What the hell is the derivative of that? It's just a. So some of these you needed to think about it in advance. Like this one. On the quiz that you guys had in class on this, most of you did not do this problem the easy way. You did quotient rule, and it will be a flippin' mess. But if you do a little bit of like algebra first, you could greatly simplify your life. Then the derivative of this now is just a bunch of power rule. Multiply by the power, lower the power. Multiply by the power, lower the power. What is this one? Multiply the power, and t is down there is -1. Lower the power from -1 to -2.
Like not, it's the same.
It's the same.
3 over x. It's like the same concept. Right?
Yes. So, questions about stuff from the derivatives? Yeah.
Can you just explain the blue 13 from the second step?
That guy?
Yeah.
Okay. Yeah. And this is a heads up. AP really super obsessed with tan inverse or arctan. It's written in 2 different ways. So this is the same problem. The derivative of arctan, it's a pattern you need to have memorized. And that pattern here, whoa, cool. Isaiah, what you guys doing? What? Okay. So arctan is 1 over 1 plus, because the t in tangent looks like the plus sign. It does.
It does not.
It does.
I remembered it. It's like not anymore, but
Oh, wait, I was doing
Not
It
anymore.
does look like.
threw it up. Forgot all.
I
Yeah,
was
threw it
just
up.
I was doing
Yeah,
1 over
you did
square
double
root.
root.
I had to look all of that's what I was doing.
Squared. Yeah.
And then chain rule. What is the derivative of 3 over t? Negative 3 over t squared. So this, guys, this actually cleans up a bit. So that negative 3 over t squared, 1 plus 9 over t squared, distributing that out. That is what the derivative cleans up to be.
I was doing 1 over square root, which I think was.
Okay,
That one's like sine and cosine.
Ooh, but it's not.
How do we go from?
Okay, hold on.
I mean, it is, but it's different. Like, it's
no, 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 so
If you
it's kind of right. The derivative pattern for arc sine. And there is no actual math reason for this. I did the proof for them, but my fake math reason, sine begins with the letter S. So we have square root, squared, and subtract. We learned sine first, so the 1 goes up front, and then we got that squared. That is the derivative pattern for arc sine. It's with S, so you have a square root, a subtract. I don't know. just throwing math gang signs at me.
Whoa,
I don't know what to do.
whoa, whoa.
Yeah.
Wow. She got the blood.
On the right side.
8.
No, I just did it right.
Oh, this is a deep recording.
Okay.
Oh, it is.
Oh, it is. It
Oh,
is.
it is. Just edit that one out.
Okay. Sine inverse of sine of stuff. What is that? Okay.
Isn't the sine inverse of sine? It's just. I mean, I was gonna
What
say-
is the square root of, what is square root of x squared? Just x? So this square root and its inverse function
just fine.
spits out x. This
Well,
sine
is the absolute
inverse.
value of that?
We really-
Yeah,
Like, just
that was on me. I had
Okay, so
visual.
as it's, some of these are tricky to see how the simplifications happen, but this is why prerequisites were prerequisites. Like, can you do these simplifications using your algebra, using your pre-cal, using your trig? Because if you can, life is a lot easier.
But like, I have no, what did you just do with the root x?
Okay, the point of showing you this was to say square root and squared are inverses of each other. They're inverse operations. And when we did one earlier that was e to the ln of something x, e and ln are inverses of each other. This is really just saying y equals x. This one is just saying y equals x. This one is saying, all right, y equals 5x.
In the y, in the inverse one with the square and stuff, would you have to say like it's the absolute value of x, or I mean, is that like
This is already restricted. Square root of a negative is, those numbers are already thrown out, so the domain is restricted, which is why I didn't write it the other way around. So you were gonna ask. Huh. Okay, can we do today's thing, or are there more questions about tricky stuff or derivative stuff in here? This is posted. My answer key is not super wonderfully visible, but there it is. Is it not there? It's posted as part of the flip chart, Maya. Okay, I will try to post it as a file itself. I just don't know where to put them. Okay, so back to today. So derivatives were finding the slope. We wanted to know the instant rate of change. Integration. What is integration? We undo derivatives by finding area. We'll have a talk about it. We'll see. Don't.
I bet you're talking about like the exit card type thing.
Oh yeah, there's an exit card on Monday on Delta Math.
Oh, it is on them.
Yeah, because
Nice.
I
Oh, thank you.
Sport,
what?
when we practicing the Delta Math, so you just want to switch it up on us.
Right. You'll be practicing on Delta Math. There is a Delta Math homework tonight that is due on Monday.
Great.
So it's a little bit tedious because
A little bit or a lot?
a little bit depends on how the dice get rolled for you on what Delta Math selects. I did not deliberately assign the irritating ones just to you. I did give a few to Walter.
All right.
That makes me feel better.
Spread the love. Okay. But here's my one and only attempt at trying to explain why doing integration is really just finding areas. Here's my attempt. Okay. Let's just say we have some object. The ball is rolling 3 feet per second. Rolling at a constant 3 feet per second. Velocity, 3 feet per second. The ball has rolled for 4 seconds. How far did it go? 12 feet. Yeah, because 3 feet per second times 4 seconds gives us 12 feet. Well, this thing was a height of 3, and that much for 4. So it's the area of a rectangle, just a big old square.
Yeah.
All right, so now, we're gonna get fancy and tricky, and we're gonna say, well, you know, it doesn't really go constant. Maybe it got tired, and it did stuff like that, but you know, a little engine that could, it get a little faster, and then faster. Yeah. We're gonna approximate this. I told you yesterday, we're just gonna find a bunch of little rectangles. And we're gonna add up all the little rectangles. So here's where the tedious comes in, because if I say, you gotta find 500 rectangles, go. That won't be on the quiz.
490.
499? No,
That's for game.
just Natalie. I'm gonna give her 1,000 and some.
I'm cool.
David, 2.
Whoa.
I will-
Oh,
Nick,
perfect.
I get
Truly
1.
burn this whole
I do too, that's
I
fine.
would do that.
Once he gets like 50, right?
Like,
Okay, so Natalie, what was your question?
I was gonna, you don't learn.
Okay, moving on.
What?
Okay.
Going aliens on
All right.
Oh, you do not want to know.
When a student says that, you're right. I agree with you solidly.
And she starts it.
Yep. Okay, so here we go. We have this particle, starts at 0, and its velocity is t squared. And we want to know how far did the little thing go if this is its velocity in 3 seconds. All right. Oh, those aren't rectangles.
Oh, those are
Well,
rectangles. No, those are. I see.
I'm gonna see the rectangles and everything.
All right.
That's the worst thing I've ever heard. It was terrible. He
What?
said you just have to see the rectangles and everything as if that makes any sense.
Okay.
It's right stuff.
I don't know, I can't think of what's over it. But I love how cool it looks.
You okay? Eric?
It's crazy. Lots of squares.
No, I'm not.
Okay. You kind of knew that, but
Might need to send him to counseling.
okay. So here's the deal, and here's what the exit card is on. We're gonna make rectangles, and when we make a rectangle under a curvy thing, we gotta figure out where are we gonna choose the height of that rectangle. All right, let's look at this problem. For each of these, the curve is y equals x squared, and I need to tell you how are we gonna make those rectangles. There is LRAM, RAM. RAM stands for Rectangular Approximation Method. And this one is MRAM. What do you think L stands for?
Lower.
Left.
What?
Left. Okay, so
Yeah, that's. I mean, I don't know my left and rights, but I'm
Okay.
pretty sure that is none of them left.
okay, stop. So to explain, I need to make
You use the left end with the right.
Oh, MRAM is the one that's right.
what?
No, because it goes only slightly, it works. MRAM is the one that works.
Middle.
Okay,
Nailed it.
You have to eyeball the middle.
I'm gonna put it right down.
okay, listen, how we're gonna do this.
Oh, I see what you mean. Okay.
LRAM, it's saying choose the left side to find the height. Okay, inside of what? The directions here. We're going to make 6 subintervals. So we're gonna cut from 0 to 3. We're gonna cut it into 6 pieces.
Okay.
From 0 to 3, how wide is each little slice? 1/2. Because 0 to 3 is 3 units. Cut into 6 pieces. Each slice is a half. So this is 0, 1/2, 1, 3 halves, 2, 5 halves, 3.
Is there? Oh, yeah. See, so wait, but like if it was for the left. Right,
Hold on. So for the left,
that 0 to 1/2 is like basically nothing. Do you see what?
yes, I do.
Okay.
I know what
and
you're
then
talking about.
the other one I can kind of see it, but I can't see it on the.
Don't understand what's going on yet?
Not really.
I
No.
don't understand.
Okay,
You said rectangles to make it.
Okay.
Make things easy.
it is. All right,
I trust you.
I-
trust
cool.
you.
Here, we're gonna find the area of this first rectangle. The height using LRAM, choose the left side. So the left side of this slice is when x is 0. What is the height when I plug it into the curve? Yeah.
You were just demonstrating because that's.
Right, well,
Zero.
the height is 0 times, what is the width of that non-existent
One half.
pancake rectangle? 1/2.
Yeah.
Okay, now my next rectangle, this skinny little itty bitty teeny tiny thing, choosing the left side, so x is 1/2. How do I find the height? Plug it into this. The height is where it hits that curve of x squared. So 1/2 squared, and what is the width of the rectangle?
For 1/2.
1/2. Okay.
So it's 1/4 times 1/2, so it's.
In this one, all of my rectangles, it said make them equal length slices. So you guys
so if
said
you wanted to be
cutting.
more accurate, you could make them different lengths, slices, because it would be like. You don't need it to be as. You need it to be more accurate at the end, but not.
So here's what we're doing.
I can't really tell.
Why does it always default to left?
So we said 0 to 3, and we said 6 rectangles. Yes?
Yeah.
So that first rectangle wasn't a rectangle at all because the height was 0. Then the second rectangle, the height was when x was 1/2. We go up to here, find that height. The width was 1/2. Now here, x is that left end point. X was 1. Plug it in. 1 squared is 1 times 1/2. Here now we're at 3/2 or 1.5.
2 points.
1.5 squared, 2 points on. 2.25 times 1/2. So 6 rectangles, find those areas, and if we added them all together, we get 6.88. The other example that I had up there, the one in the middle, it says, don't use the left end of 0, don't use the right end of that first box as 1/2, pick the midpoint. What's in between 0 and 1/2? 1/4.
But your width is still the same.
The thickness, the slices are still 1/2.
Right, and in
So-
between each half, it's still.
So what the L, the M, and the R stand for is, where do you find the height of the rectangle? Do you choose the left side to find the height, the right side to find the height, or the middle? So here's right endpoint. And you guys always do LRAM wrong, especially if the first rectangle is flat like a pancake. You're like, oh, you have this sympathy thing, and you're like, well, he was just 0, so we should do another one because that first one. Nope. No.
Over 4 units off.
Okay.
So how do we know which one says midpoint the most exact?
That's no. But in this particular case, for this particular problem, like if I do RRAM, I'm over-representing. These like rectangles are hanging out over the curve. It's like, yeah, it's all rosy and good. Woo!
Well, isn't it the
Versus-
same margin of error as the left side?
No.
It's 3 square feet.
And
Can
okay.
you explain to me why?
Today, no. But it depends on the curve itself. And how,
That's good.
okay.
Bring it
Just
from
hold on.
approximately to 3
Yeah, I
square
wanna-
feet.
Could you
So-
take the 3 and I don't know if this is gonna be. Could you take the 3 and then average them out, and would that be more exact?
Okay.
Because if they're not the same, then like I don't know. Maybe it was stupid.
Okay. So doing these left ones, if we added them all together from the left side, we would get a number like 6.8. Doing all the stuff on the right, we'd get a number like 11 point something. Doing the midpoint ones, we're going to get 8 point something. The actual answer, for those of you who know how to do this, is 9. So midpoint ended up being, in this case, only, Eric, the best one. But Eric, it depends on the curve. If the curve does funny business, if it's more wildly steep, those rectangles are going to be more off kilter. So, and in here, we don't care about specifics of how much error, just is it an over approximation or an under approximation? So let's look at getting myself confused because I'm using two of my flip charts. Okay, this one is my adding up of all the rectangles. Mikhail, is it going to be an over approximation using the rectangles or an under approximation about the?
I'm gonna guess under.
You're going to, I guess, under. What makes you say that?
Well, I'm just using my context clues because like what's the rectangles that under?
Because there's a little white space between the rectangles and the curve. So this is an under approximation. This one, I'm not going to ask you about. This one, Will, is it over or an under?
Over.
Over, because all the little rectangles are hanging out over. Okay. Brooke?
But why are you not asking? Just because it's like.
Because it uses a different rule, and I don't even ask BC Calc about this one. They're like, oh, we'll just ignore it, and they never ask. Don't ask.
That's a great.
Okay, but
That's
but
a great model.
we will ask for this one and this one. Why is it under? And you can't just say because it looked that way. You need to give me a math reason.
Could be the area of the rectangles. I don't know how to. I guess I don't know.
The height of the rectangles is underneath.
So I will give you some choices. Is it because the function is concave up, concave down, because the function is increasing, or because the function is decreasing? It is definitively one of those.
Because I'm.
Concave up.
I was
I
gonna
was
say
the
increasing.
same explanation.
If the function's increasing and you put it on the left side or whatever, then it doesn't like. Do you know what I'm saying? I don't know how to elaborate on this. If the function's increasing and it's on the left side, then there's going to be area that in between that you're
Okay.
not covering.
Okay,
That's
so
not mathematic. But like,
okay, let me see. He said, if your function is increasing like this, and you are chosen to do LRAM, so you're choosing the left side as to represent your height, you're picking the sooner point, and it's all going up from there. It's going to be an under approximation because we chose this left end point, and it was rising from there, but we're lowballing, we're getting an under approximation. So this is an under approximation because we were using that left end point stuff, and it was going up. So the reason for this one, it's an under approximation because it's increasing.
it's vice versa if it's going the other way.
But going the other way around, if it's increasing, you choose to be like, well, I'm going to estimate things using a bigger value and then go that way. That first rectangle, it was 0 here, but now it's like big and chunky. And midpoint, that one is really hard to rationalize, and that uses concavity, and I don't ask. Don't ask, don't tell. Dave is fine with that. He's like, all good. So, I want to see, and this is the kind of problem we're going to do and make Natalie do.
No.
She gets to do 1,000 rectangles, but the point of this, yes, trapezoid is tomorrow. But if we did lots and lots of rectangles, what do you think? It's going to get more accurate, less error, more of a pain in the ass, right? But the LRAM, the RM, like if we do left or right, it'll be closer to accurate. Abby?
I don't have a question.
You don't have a question.
What is like the solution? Like
What is-
the answer to that problem that we just did? What did we solve?
What did you solve? I didn't finish it because I want to do the problems with you guys.
So we did a step and using the integral.
Hang on, So finishing that problem, If we found all of those areas of all of those rectangles and added them together, using LRAM, we would get about 6.875. If we used RRAM to find all the rectangles using the heights from the right side, we would have gotten 11.375, 11 and 3/8. And MRAM just is such a pain. It would be these guys. And it comes out to about 8.94. Okay. So, what I want to do with the 13 minutes we have left is one of these.
What?
She's not doing this crap here.
Oh, appreciate it.
Are you completely done?
Yeah.
On the handout that you just got,
Yeah, over here too.
you get one in and one for
No, there's discrimination.
Okay.
We can't see the board.
So can you guys put a thicker line where the axes are so you can see where the 0, 0 coordinate is?
Oh, yeah. So I just put it on the wrong way.
And that'll make an impact.
Mm.
So
Oh.
here's the X and Y axis. And I'd at least like to work through LRAM for the first one. And first we got to see what are we integrating over? What X values? Brooke, looking at the paper, X goes from where to where? Where?
I'm sorry, what did you say?
Reading the problem.
X equals 1 to X.
1 to 3. Okay. So from 1 to 3, we want to estimate the area under there using how many rectangles, Nico?
2.
Read the problem.
Oh,
4. Dang. 4. So how big is every little slice that I'm going to cut? So I need to go 2 units and I need to cut it into 4 rectangles. Each slice is a half. So those are my rectangle heights in there. Jaden, for this one that says LRAM, am I going to find the height using this left side, the right side, or something in the middle? The left side. So here's the first rectangle with that LRAM, the second rectangle, third, and fourth. Right? Good? Okay, so let's find,
Oh, okay.
I'm going to find 4 rectangles.
And that's how you do it. You write A1, A2, all that.
There's
Like
lots of, whatever organization method works for you, but be neat about it.
Okay, I was just asking because like there's no notation. It's like required
Right.
here. But, I got
There's no fancy special notification or notation. And that the function we're using is this gross thing here. By all means, please use a calculator for the tedious plugging in of numbers. But, so, bringing up a calculator. So going to y equals putting in x squared minus 2x plus 2. And do you guys know the quick way to tell the table to give you nice numbers or the numbers you want? No? Okay. Above window is that little yellow, it says table set, TBL SET. Hit the second table set, starting at 0 what does delta mean, that little triangle? Change over time. So I wanted the steps to be, you guys told me 1/2. So if I put 0.5 in there, and now if I go to second graph, that'll show me the table. Where's my first y value that I want for the height of that first rectangle that Jaden told us to do? At 1. So the first rectangle starts here. First rectangle starts here. So when x is 1, the height of that first rectangle is 1. What was the width of this little rectangle? 1/2. All right, second rectangle. The height at what is this x value right here? 1.5. So go looking at the table on the graphing calculator. Whoa, holy moly. Awesome.
1.25.
So 1.25 right there. What was the width of the rectangle again? Still 1/2, right?
The one, what was the street, 1.25?
1.25. The calculator looking at it, 1.25 times 0.5.
1.25 is the height?
Yeah, because we looked in the calculator when x is 1.5, plug it in, I got 1.25. Right, what's the height for the third rectangle from going to the left side
Wait,
when x is,
but isn't it from 1 to 3? Aren't we from 1 to 3? So I feel like okay, never mind.
yeah? So Ray,
Oh,
what is,
1.5. Okay.
this was 1.5, 2. When x is 2, I need that height there. So looking at the calculator, when x is 2, the height is 2.
How'd you get to the table again?
How do we get to the table looking at the calculator? Second graph is table.
Thank you.
But, well,
Gives you all the easy guys.
but I had to do something first. So if you didn't do that something first, second table set, I said start at 0. I should have said start at 1 because that's
Table is what, 1.5?
the table, delta table. Our steps were 1/2 each because you said I'm taking the distance from 1 to 3, which is 2 units, and Brooke said cutting that into 4 pieces, 2 units cut into 4 pieces, each unit is 1/2. Okay? So now my fourth rectangle and last one, I need the height at 2.5. I am never going to use that height at 3 when I'm doing LRAM. Height at 2.5 is 3.25.
And you're never going to use 1 when you're using RRAM.
Correct. So, I don't know what those things are, but we can now use our trusty calculator. Yay. So the first rectangle, 1/2, plus the second rectangle, 1.25 times 0.5, plus the third rectangle, 2 times 1/2. Well, I know that one's just 1. Plus the fourth rectangle, 3.25 times 0.5, and I get a syntax error. Go me. Plus. Well, second entry, back that up,
Hey.
and insert a 1. Take that. I was about to say a word that I can't say because I'm being recorded.
Mother function.
Okay?
Yeah.
So using LRAM, we got 3.75. Using RRAM,
Oh, that's what I did.
using RRAM, I need all those same calculations, but the last, so this A2 is this guy. And this height, I'd have to plug in 3 to get that value up there. The height at 3 was 5 times a half. So sorry, that's wrong. So using RM, I would add up those 4. Ignore the first one and create a new last one. My analysis is making any sense.
5.75 is what is there too.
How do you use
Five,
two
five,
R-
How do you get the 5?
Okay,
Where's
the RM,
reuse something.
The
Alright.
one half comes.
RM and LRM are going to be exactly the same, except the first rectangle for LRM, I'm not going to use that one. So let's see. Alright, so for LRAM, we went from here and got that rectangle. And for the first one, this was the second one. Well, I'm not doing halves, sorry.
So the first one got the same height as the second one. First one's an RM and the same height as the second one.
Yeah, so I ended up using these 3 rectangles again, except they extend to the right. So I needed to, like that first one's not there, and the last one, I needed to calculate. All right, guys, try some of the delta math tonight. That's a little bit long. Pick a few to do. The whole thing is due Monday, but try some of them today. Mikhail?
So this is like, we need to keep for the entire.
Keep this packet till for a bit.
Are we gonna do work in this packet?
Well, it's not like, you should do the front page tonight,
We're not doing that.
because I said so.
I thought we were doing that.
Eric, because you said so. That's the front page. Most of the calculations have already been done.
We're not doing it.
That is true.
You should do the MRAM too, which is why I'm asking you to try this out.
What is a negative control?